Okay, so moving along to our next module, today we're going to talk about user-defined functions. We've already seen functions that we can call using libraries such as cmath. Now we're going to see how we can make our own in C++, and this is a really powerful concept. So the predefined functions, they get organized into these libraries. There are I/O functions, such as those included in the I/O stream header. A lot of math functions in CMath, obviously. We saw pow, square root, floor, and we even saw one that calculates the hypotenuse for us. There's also the trigonometric functions. So there's a lot of different functions that you can get in the math library. And basically, you need to include the library and the pound include statements, those preprocessor directives, and table 6.1 in the Malik textbook has some common predefined functions if you'd like to take a closer look at some of those that are available. But functions that we write allow us to divide complicated programs into smaller, more manageable pieces. So they act like miniature or smaller programs that can be combined to form larger programs. And this has a number of different terminologies, so you know it's important. It's all known as stepwise refinement, functional decomposition, and top-down design. And I like to use the metaphor of this is exactly how Johnny Cash stole the car. He had a song called One Piece at a Time, which is he was working in an automobile factory and he wanted one of the Cadillacs they were producing, but he didn't have the money to get the Cadillac. So what he did is every day he went in and snuck out a piece of the Cadillac from the factory and built the Cadillac. Of course, as you can see from the picture, there were some complications. Namely, he did it over several years, so the Cadillac he ended up building was from several different model years, and it's a really funny song. And some of his fans that are pictured here with him actually built the car according to the specifications in the song, and so they gave him the car, and so that's Johnny Cash's Cadillac. But functional decomposition allows us to build something far more complicated by making smaller pieces of it and getting those individual pieces to work one at a time. So one piece at a time. And this is the real way to achieve modularity, or to break up the program into smaller, more manageable chunks. There's cosmetic modularity, which is something you've already seen, where we might separate the declaration of variables from the input, from the processing, from the output in a C++ program. But functions allow us to make basic building blocks that are even more separate than that. So what we need to know is how to use or invoke a function, which we've already seen with those predefined functions, and how to write the function itself. So there are three parts to a user-defined function. The first of these is the function declaration. That goes at the top. It's sometimes referred to as the function prototype, and it goes before main. So it does go at the top, and it'll have a semicolon at the end. Things that it tells us the return type, like in this example, double is the return type. The name of the function comes next, which in this case is cost, and the parameters, which are quantity and price. Quantity is an integer and price is a double. Those are the pieces of information we use to calculate the value that's returned by the function. So this cost function here is going to give the cost of a quantity of items at a given price. So when we dissect this, we have the return type, which is double, the name, cost, and the parameters, which are quantity and price. And the function name along with the parameter list are known as the function signature. Now, you can't have two functions with the same signature and the same namespace, but we will see how we can have two functions with the same name and different parameter lists a little bit later on in this module. The definition tells us how we actually accomplish the function. So those are the declarations, the assignments, the loops, basically the calculations that we're going to go through. And for a pure function, it needs to have at least one return statement that gives us the value back that we're calculating. This goes after main, and it doesn't have the semicolon after it. So here's how we would do our cost function. We would simply calculate the price multiplied by the quantity and return that value. And you'll notice the first line here, it does not have the semicolon like the function declaration does. So the function declaration again has the return type, the name, the parameters, and then inside of it, it would have the code that accomplishes that task. Anything declared inside of it, like this variable max, is known as a local variable. And here max is just known inside this function. So if you try to use max later on in, say, a command in main wouldn't know what you're referring to because max is only local to this function. And last but not least, we have the invocation. This takes place in the main part of the program. So basically, we use the function name along with the actual parameter. So if we wanted to see how much 24 bagels would cost, we would output 24 bagels cost and then call the function cost with the parameters of 24 and 1.69, assuming $1.69 per bagel. Maybe a little bit expensive, but that would give us the price. Another example, this one's taken from Malik, where it will return a character for a course grade, and it will be based on passing the score. It'll divide the score by 10, and basically 0 through 5 is going to return an F, 6 will return a D, 7 will return a C, 8 will return a B, and 9 and 10 will return A. It might be good to have a default case in here, but this would cover, most of what would be valid, assuming we passed a valid score. So functions change the flow of control through the program. We've already seen that a little bit with control structures, but functions also do that. And oddly enough, main is a function. I guess it's not odd, but main is a function. This is something probably used without realizing. So here we're kind of revealing a mystery. You may wonder why the int goes in front of main. It's because it's a function. So main returns an integer value. It contains variable declarations and kind of overall describes how the program is structured. And then smaller portions of the algorithm or the program get accomplished using those function invocations. Main acts as the conduit and passes data between and among the different functions. So execution always begins at the first statement in the function main, and then other functions get executed only when called. When we call a function, it transfers control to the first statement in the body of the function that we're calling. And when the end of the called function is executed, then we go back to main immediately following that function's call. A function's return value replaces the function call statement. So, if we were calculating that cost 24 times $1.69, and we called that, then the value calculated would actually replace that call after we get done executing those statements. So in a classic sense, functions act like mathematical functions and they return a value. We will talk about procedures, which are subpieces of a program, and they don't necessarily return a value, or they can return multiple values. In C++, these are called void functions, and we're going to look at those in the next lecture. So thanks so much for coming along. Appreciate that, and we'll talk to you soon.